All right, so this is going on page 38 when we're done. There's not a place, like I didn't put a little line there, but you can handle it, right? And let's look at the other side real quick, just for a second, and then we won't look at it too much longer. But that side, if you fold it up like that, then you'll be able to see it when it's in your ISN. Does that make sense? Like that's how you would fold it, so that it still works out well for you. But here's all your rules, which we'll talk about in just a second. But I wanted to look at this, which is all the transformation rules kind of in one, like all the different transformations we can talk about that we're going to talk about. And we're using A, B, H, and K. That may or may not be what you've used in the past. Okay. Also, today's like transformation day because we're doing it today in AP Pre-Cal. They're doing it in Pre-AP Algebra 2. They're doing it in Algebra 3. And so this is definitely not new to you because you actually started in Algebra 1. I don't know if maybe they're talking about in Algebra 1 also. I don't even know. But you may have done A, B, C, and D. I used to teach it all the time with A, B, C, and D instead of A, B, H, and K. But the way College Board does the first part of our course, it's A, B, H, and K. Next semester, we're going to do some transformations, and they use A, B, C, and D. Why we can't just use A, B, C, and D all year? I don't know, but that's not what they're doing. I've also seen a random textbook use P, Q, R, and S. Whatever. But the letters themselves, the point I'm trying to make is the letters themselves don't matter. It's where the letters are or where the numbers are that the letters represent by what's going on, right? So if the letters are different, it's not the end of the world. All right, let me back over. So our transformations, they affect the appearance. We have two basic types. We have rigid and non-rigid. The rigid ones just move it around, flip it over, move it around. So they change the position or orientation of the function. Non-rigid is when it can get distorted. So it can distort the shape by changing its size. Okay, just so change the size of it, stretch it, compress it, whatever, right? Even though this is a review and you are very well informed on these already, we are going to talk about some of the stuff just a tiny bit different. It's not that anything you've done in the past it's wrong. It's just different ways to say things. And we have to be very specific for what College Board is expecting from us. So might be a little change in just some terminology for you. But okay, so if we have a translation, which is a shift, but we're big boys and girls, so we call it translations, right? If I'm going to go up and down, those are my vertical translations, right? That's going to affect my Y values. And so I take f of x, which that is my y. If I'm going to shift it down, then I subtract some value that we call k. If I'm going to take a function and shift it up, then I take f of x and I add k. Right? Nothing earth-shattering here. It's all old news, right? Okay. If I'm going to shift left and right, those are my horizontal translations. What do we know about x? X is a what? A liar. X is a liar. Y does not lie because he's a nice guy. X is a liar. So if I have f and it's going to affect the x, if I'm going to move to the left, it's going to be x plus h. If I move to the right, it would be f of x minus h because x is a liar. You do the opposite. Okay? That sound familiar? Yes. X is a liar. Don't forget that. All right, when we talk about reflections, if I have a point right here, which we can call xy, if I reflect it and it ends up right here, what changes, the x value or the y value? The y. This would be x negative y, right? So if I change the sign on y, that's a reflection in the x-axis. So y is my f of x. If I change the sign on that, that's out here. Okay, bless you. If I have a point right here that's xy, if I reflect it in the axis, it ends up over here. That would be negative xy. So when I have a reflection in the y-axis, I change the sign on x, so that would look like f of negative x. Okay, everybody good with that? Okie dokie. So then dilations are stretches and compressions. Even though we still do need to know if it's a stretch or a compression, and that is important, the word dilation is really what we're using for all of them, all right? We have one big box, but I'm going to put like 2 rows of information, just kind of letting you know before you write real big. But a vertical dilation, a vertical stretch or compression, I'm either, and again, this is a vertical thing, so it's affecting our y. It would be like a times f of x whether it's a stretch or a compression, A times F of X. What makes it a stretch or a compression is the value of A. If it is a compression, then the absolute value of A is between 0 and 1. And we do absolute value because if it's negative, that's taken care of with the reflection. We don't care about the negative. We're looking at the absolute value of it. Is it AK? No. And then the absolute value of A is greater than 1, then it's a stretch. That kind of does look like a K. It's like a funky K. All right, that makes sense? You multiply something out, well, you multiply anything, it's a dilation. You multiply it out in the front of everything, that is your vertical. If we are going to have a horizontal dilation, that's going to affect the X. So this would be F of B times X. Okay, but X is a liar. So if it's a compression, then the absolute value of B is greater than 1. Because if I see F of 3X, it looks like it's going to get bigger, but it's really a compression with a factor of 1/3. And if it's a stretch, then the absolute value of B is between 0 and 1. Okay? So it looks like the opposite. Oops, sorry. So we talk about it being dilated vertically, or we have a vertical dilation. That's with our A. That's just whatever the absolute value of A is. Okay, that's the factor. If it's going to be dilated horizontally, then the factor is 1 over the absolute value of B. You have to take the reciprocal because X is a liar. Okay, everybody okay with that? What questions you got? All sounds familiar, right? None of it's brand new. All right, grab your other sheet of paper. This is going on page 39 when we're done. Ooh, I wonder if that's from the kidnapper. All right, we're identifying transformations. So let's write this up here. G of X, we got to finish this. G of X equals A times F of B times X minus H plus K. Okay, so that is what it looks like with all of the transformations in there, right? But A, B, H, and K would be numbers. Everything else would still be letters. There seems to be, even with this not being new to y'all, sometimes y'all still have a hard time figuring out what affects X and what affects Y. So I think I've figured out a way to kind of help you with that. When you have like an actual function, I can tell that this is a cubic, this is a square root, whatever. It's an actual parent function and not a generic function like this. Then everything that happens before you do whatever the function is affects X. Everything you do after that affects Y. That doesn't mean moving left to right, because the 2 is done after you take the square root, right? Even though it comes first, because you have to take the square root, then multiply by 2, right? So everything under the square root here affects X. Everything not under the square root affects Y. You with me on that? So you look for the actual, it's all a function, so I don't have the right words and I can't get the right words in my brain, but the function part, like when you look at a cubic, this is before, when I cube X, nothing happens before I cube X, like nothing is affecting X. You with me on that? I only have something after I've cubed it, and that affects the Y. So I only have one transformation here, and that is going to be, since it affects the Y, because it happens after the function, that means that is a vertical, and this would be a vertical what? Translation. Okay, and we can abbreviate vertical. We cannot abbreviate translation, because if you just put trans, it can look like transformation. There's lots of words that we use that start with that prefix, so that you got to write it out. Vertical translation of -4. We do not say up and down. There's no up and down. Okay, if it's negative, it's down. If it's positive, it's up. You're probably used to saying you go up 4, down 4, whatever. And that is physically what we're doing, but that's how it's going to be said to you. So you need to make sure that you understand what's going on there. We good? Okay, so over here, when I look at number 2, I'm going to box the square root. I know the 2 comes first, but it's outside. It's after you take the square root, right? But I am going to go left to right, because I think if you go left to right, writing them down, I think that's very helpful. So the first thing I come across is the 2. It's outside my box, so that makes it a vertical something, and this would be a vertical what? Okay, but what's the word we use? Dilation. Thank you. It's a vertical dilation by what? 2, because y does not lie. So that makes it a stretch, but we don't care. We're not writing that. You write dilation. Okay, so then I come across this negative. Since I'm multiplying by a negative, I know that's a reflection. Does that negative affect x or y? X, because it's inside. So if I change the sign on x, I'm reflecting across what? Y. So it's a reflection across the y-axis. All right. Then I come to this one here, and that affects x, right? Because it's inside. So that makes it horizontal, and it's a horizontal what? Translation of what? 1, because x is a liar. So it's a positive 1. Okay, we good on that? Yes? All right, let's look at the next one. So I'm going to box. This is going to be a quadratic, so I'm going to box everything that would be with the squared, right? Nope, because that's outside. That's the negative happens after you square it, not when you before it. So it's outside. So, but I'm going to start with the negative though. And is that negative? Well, I know that makes it a reflection. And does that negative affect x or y? Y, because it's on the outside. So if it affects y, it's across which axis? X axis. Okay. If it affects the y, we reflect across x. Okay. Then I get to the 1/4. Does that affect x or y? Is it inside the box or outside the box? Inside. So it affects x, which makes it a horizontal what? Dilation. Good, because I'm multiplying. A horizontal dilation by, think about it, x is a liar, 4. 4. You take the reciprocal. Okay, because x is a liar. And then a vertical translation by 6. Okay. She says what? Right. Yeah. Okay. So then on 4, we have this absolute value. So everything inside the absolute value there, I'm just going to box the whole absolute value, really. So I come across that 3 first. It's inside, that makes it horizontal. So horizontal what? Dilation by 1/3. Very good, because you got to take the reciprocal. Okay. Then that 5, that's inside, so that is a horizontal what? Translation of -5, because x is a liar. This 2, that's outside my box, right? So vertical what? Translation of -2. All right. What questions do you have? We good? Yes? Okay. All right. So on 5, we're going to box this. Yes? It's not 1.5, it's just 1/2. Okay, good. So that means that is a what? Vertical dilation. Good, because it's being multiplied by 1/2, because y does not lie, because he's a nice guy. Then I come across the 6, that's inside, so that is horizontal, and it's a horizontal what? Translation of 6. That 2 doesn't mean anything because it was just a quadratic, right? Don't be doing weird stuff with that, with those things. Okay, we good with that? So all of those beforehand we could identify as absolute value, square root, quadratic, whatever. Now the rest of these are all generic functions, which you can also be asked for. So when you box these, we are boxing the f of part, f and whatever's in those parentheses. That's basically what happens inside that function, right? When you actually do the square root, or you do the square, or you do the whatever. So then when I start with this negative, I know that's a reflection across which axis? X-axis, okay. And then we're going to have, this is going to be a horizontal dilation. Good. Horizontal dilation by 1/4. And then we have a vertical translation of 3, right? And the positive and negative on the translations tells you whether you go up or down or left or right. Okay, we all good on those? Yes, okay. All right. So here, we're going to box this, right? So I start with the negative. That's outside that box. So that is a, I'm about to write vertical. That's not what I want. This is a reflection across which one? X-axis. Then the 4, that's on the outside, so that is vertical. It's a vertical what? Dilation by what? 4. Okay, it's a positive 4 because it's the absolute value and y doesn't lie. Then I come across the 1, so that is a horizontal what? Translation. It's a lie, yes. Translation of what? -1, because x is a liar. Very good. And then a vertical translation of 2. Okay. This easy peasy, right? Relatively easy. Yes, it should be. We're just reviewing this before we get into the rest. So I'm going to box this one. This one's crazy easy. We could probably skip it, but we'll do it anyway. This gives me a horizontal translation of what? 5. And then a vertical translation of -1. Okay, everybody okay with this? Why the signs are what they are? Yes? All right, I want you to work on 9 while I hand out the assignment, and then I will work it with you. What is today? Tuesday? Yes. Okay. All right, so that's what I'm boxing. So I'm going to start off. I want to make sure I finish before the announcements come on. So I got a reflection across which axis? Y-axis. That 1/3 means this is a horizontal dilation by 3. We all agree with the 3? Yes, because X is a liar, right? X is a liar. You got to take the reciprocal. And then we have a horizontal translation of 4. Good. And then we have a vertical translation of 7. Okay. Questions? Anything? I need to clarify anything? All right. So here, I'm going to box this one. The negative is a reflection across which axis? X. That 3/2 is on the outside, so that is a vertical what? Dilation by 3/2. Now, is that a stretch or a compression? A stretch, because it's greater than 1. Just because you see a fraction doesn't mean it's a compression, right? Don't fall into that trip. Then I have a horizontal translation of -3 and a vertical translation of what? -8. Okay. Questions? Yes. Dilation is when you multiply. Translation is when you add and subtract. Absolutely. We good? Any questions? All righty.